Okay, so we're going to talk about stoichiometry and a couple of different types of stoichiometry problems. I'm going to talk about two problems in this video, and then we'll do another short video with two other types of problems you might see. So stoichiometry is calculations involving a chemical equation. So you're always going to have some sort of reaction that you're talking about. In this case, we'll use this reaction as our example, and you can read this reaction kind of like a recipe. And what this recipe tells me is it takes 4 irons and 3 oxygens to make 2 iron oxides. Okay? We have up here what we call the mole map, and this kind of gives us an idea of what we need to do to get from point A to point B in a problem. So these shows us what our possible steps can be. So we'll see how to use that by using an example right here. This problem says, how many moles of iron oxide can be made from 0.5 moles of iron? So if I look up here at my mole map, I am starting with, I know a certain number of moles, and I'm trying to find moles of my other substance. So I know moles of iron, I'm trying to find moles of iron oxide. So if you notice, this is going to be a one-step process. In order to get from moles of something to moles of something else, I'm going to look at the coefficients in my balanced chemical equation. So I notice, for example, down here that it takes 4 moles of iron to make 2 moles of iron oxide. So when I'm doing a stoichiometry problem, my first step is always going to be write down what you know. So in this case, I know 0.5 moles of iron. So I'm going to write down 0.5 moles of iron. And then I'm going to take this number and I'm going to multiply it by a fraction. Okay? That fraction is going to be, in this case, based upon my coefficients in my chemical equation. So this ratio that tells me I need 4 irons for every 2 iron oxides. The way that I set up these fractions is whatever units are right here should go on the bottom of my fraction. So since this says moles of iron, on the bottom here, I'm going to put moles of iron. Then I want to look at the problem and say, well, what am I trying to find? And if I look at the beginning of the question, it says, how many moles of Fe2O3 will I get? So that's what I'm trying to find. So what I'm trying to find will go on the top of the fraction. So the way I think of it is, you get the units that you have, and in the fraction, the units that you have should go on the bottom, and the units that you want should go on the top. So if starting with moles of iron, so moles of iron should go on the bottom, moles of iron oxide should go on the top. Where I find the numbers to plug in is I look over here at my chemical equation. So notice that my chemical equation, my recipe, tells me I need 4 irons, so I'm going to put a 4 there, for every 2 iron oxide. So I'm going to put a 2 here. And if I plug this in my calculator, I'm going to literally do what it says here, 0.5 times 2 divided by 4. So 0.5 times 2 divided by 4. This gives you 1 divided by 4. Plug that in your calculator. When I turn it to a decimal, that's 0.25 moles of iron oxide. Okay, and that's my final answer there. This problem is going to be what we call a grams to grams problem. So if I look down here, I see what's given to me is 10 grams of iron oxide. And what I'm trying to find is how many grams of O2 would I need in order to make this much iron oxide. So just like I did up here, my first step is I'm going to take the number given to me in the problem and I'm going to write it down. 10 grams Fe2O3. Then I might look here at my mole map and say, well, how many steps is it going to take me to get to the answer? I'm starting with grams of one thing, my known, and I'm trying to figure out grams of something else. So if you look at your mole map, you'll notice it's going to take you 1, 2, 3 steps to get there. So you might even go along and set up 3 fractions, because you know it's going to take us 3 steps. The first step, going from mass to moles, I'm going to use the molar mass, which I find on the periodic table. Okay, so if I look up the mass of iron, I will see that each iron weighs, I'm looking at my periodic table, each iron weighs 55.8 grams. Okay, and I have 2 irons, so I'm going to add those up. And I have 3 oxygens. Each oxygen weighs 16 grams. So I'm going to take I'm going to add 16 3 times. If I add that all up, I will get, and I'm going to add that right now on my calculator, 55.82. You should get 159.6 grams. So that is how much 1 mole of iron oxide weighs. So the number on the periodic table tells you how much 1 mole of that substance will weigh in grams. So here's my ratio. 1 mole of iron oxide weighs 159.6 grams. Now I want to figure out, well, how do I set up this fraction? If you remember what we set up here, the units that we have should go on the bottom of the fraction. So since we're starting with grams Fe2O3, on the bottom I should have grams Fe2O3. And on the top should be whatever I want. So if I'm starting with grams, my next step is I want to find moles. So on the top of my fraction, I'm going to write moles Fe2O3. And that info on the periodic table that I just calculated tells me that 1 mole of Fe2O3 weighs 159.6 grams. So now I've just figured out how many moles of Fe2O3 I have. Next step, remember I want to get over here to the end, next step is to go from moles to moles. And just like I did in this problem, when going from moles to moles, I'm going to use the coefficients. Okay, in this case, the units that I have are moles of Fe2O3. So whatever units I have right here should go on the bottom of my fraction. So moles Fe2O3 will go on the bottom of this fraction. What I'm trying to find will go on the top. So I'm trying to find O2. So on the top, I'm going to put moles of O2. And then I'm going to look over here at the chemical equation, and it will tell me I need 3 O2s for every 2 Fe2O3s. So I'm going to put 3 moles of O2 for every 2 Fe2O3s. And now I figured out how many moles of O2 I need. Last step is to go from moles of O2 to grams of O2. Okay? And again, to do that, I'm going to use the molar mass in the periodic table. So to find the molar mass, I'm going to look at oxygen, and I see that it weighs 16. But I have 2 oxygens, so 1 mole of oxygen weighs 16 plus 16, so that's 32 grams. So now how do I decide what to put on the top or the bottom of the fraction? Well, the units that are here should go on the bottom. So this is moles O2, on the bottom will be moles O2. The unit that I want, which is grams, is going to go on the top, grams of O2. And so that number on the periodic table tells me that 1 mole of O2 weighs 32 grams. Okay, if you stop, now make sure that you can plug this in your calculator correctly, because I know some of us set it up right, but maybe aren't plugging it in right. So take a moment to try it in your calculator, and what you should do is you do 10 times 3 times 32 divided by 159.6 divided by 2. So you should end up with 3 grams of oxygen is your final answer. So again, what you're doing here is you're just literally doing it the way it's written. So let's say 10 times 1 divided by 159 times 3 divided by 2 times 32 divided by 1. If you plug that in your calculator, you should get 3 as your final answer. So these are 2 types of problems, mole to mole, gram to gram, and we'll make another short video doing gram to mole and mole to gram if you'd like some extra examples. Thanks.